Okay, so with example 6, a little bit different here, guys. It says find k so that x minus 4 is a factor of, and then you have this polynomial that has k in the polynomial. What you need to pick up is that it says x minus 4 is a factor. Remember, if it is a factor, then our remainder is 0. Okay, so if it tells you it's a factor, then we know our remainder is 0. And if x minus 4 is our factor, we're going to set x equals 4 or 4 inside that box. So our next step was to take the coefficients if there's no placeholders. So we have x to the third, x squared, x. This 3 plus k represents your constant. So our coefficient in front of x to the third is 1. Your coefficient in front of x squared we don't know, so they've represented that by k. Coefficient in front of x is -4, and then our constant is represented by 3 plus k. Don't let that confuse you. You're going to do the same step. So we're going to drop that first number down, and you're going to multiply. So 4 times 1 is 4. Add down. So k plus 4. And you're simply just going to write k plus 4. And then you would multiply. So 4 times k is 4k. 4 times 4 is 16. Add down. So if I'm adding -4 plus 4k plus 16, that's going to give me 4k. -4 plus 16 is 12. Multiply again. All you're doing is distributing. So 4 times 4k is 16k. 4 times 12 is 48. And then we're going to add. So you have k plus 16k is going to give us 17k. 3 plus 48 is going to give us 51. So we're showing that our remainder is represented by 17k plus 51. We're trying to find k. And you know that your remainder was supposed to be 0. So you're going to take this 17k plus 51, and we're going to set that equal to 0, and we're going to solve it. And then we're going to know the value of k. So you would subtract your 51, divide by your 17, so k would be -3. Example 7 is similar. It says, given that you have this polynomial p of x, if the remainder of the division of p of x by x plus 1 is -11, so our remainder is -11, so I'm going to put that r equals -11. What is the remainder when we divide by x minus 1? So they're telling us when we divided this polynomial by x plus 1, it has a remainder of -11. We're going to then divide by x minus 1 to find what the remainder is. So if my factor was x plus 1, we're going to put x equals -1 into our little box. So -1. Look for placeholders, x to the third, x squared, x, and we have this constant that's represented by k. So we're going to put 1, -2, 12, and then k. Drop your first number down, multiply, add. So that's going to give us +3. Add down to get 15, and then we've got -15. So we've really got k plus -15. Well, you know plus a negative is really k minus 15. So again, think about what that represents. That represents your remainder, and our remainder was equal to -11. So you're going to take this k minus 15, k minus 15, and we're not going to set it equal to 0 because it told me the remainder was -11. We're going to set it equal to -11. So you would add your 15. So k is going to be 4. So now we know what we can replace this k with to divide the polynomial by x minus 1. So you're going to do the whole process over, but we're going to be dividing by x minus 1 this time. So this time positive 1 is going to go in our box. So you're using that coefficient 1, negative 2, 12, but I don't need to put k. I know what k is. K is 4. So first number comes down, multiply, add, multiply, add, multiply. So then you can see that your remainder is 15 when you divide by the x minus 1. So that's our answer there. The last thing we're going to talk about is called the remainder theorem. So don't get it confused with the factor theorem. It says when a polynomial f of x is divided by a linear polynomial x minus a, the remainder of that division will be f of a. So basically it's telling you that whatever you substitute in, so notice this was a and we're going to substitute a in, the remainder is the division of that. Okay, so the first example gives you your polynomial and says find f of 3 using the remainder theorem. So you're simply going to sub f of 3 in. So we're going to have 2 times 3 to the 4th minus 15 times 3 squared minus 8 times 3 plus 3. So 3 to the 4th is 81. 3 squared is 9. 8 times 3 is 24. So then we're just combining. So this is going to be 162. This is going to be minus 135 minus 24 plus 3. And you could put all that into your calculator in one step. So let me do that one more time, just to make sure I've got that right. Yeah. So basically what you've just figured out is that the remainder is going to be 6, based off of the remainder theorem. You've got your turn. It says use the remainder theorem to find k in this polynomial. So I'm going to do this one with you real quick. So we're going to find, it says f of 2 equals 28. So this tells me what I'm substituting in to my function. So we're going to have 6 times negative 2 to the 4th plus 5 times negative 2 to the 3rd plus k times negative 2 minus 100, and I know that that has to equal 28 because they told me that it's going to have a remainder of 28. So now we're going to simplify. So negative 2 to the 4th is 16. Negative 2 to the 3rd is negative 8. K times negative 2 is minus 2k minus 100 equals 28. So then we can combine like terms here. So this is going to give us 96 minus 40 minus 2k minus 100 equals 28. So we're going to get negative 44 minus 2k equals 28. I'm going to add that 44. Okay, so guys, I just realized I made a mistake here. It's supposed to be minus 5x to the 3rd. So we're going to change this to a minus. Sorry about that. So negative 5 and negative 8 is going to be positive 40 here. So that's going to change things up a little bit. So we're going to have 96 plus 40 minus 100, which is going to give us positive 36 here. Got a mess for you guys, which means we're going to subtract 36. Apologize for that. So then we'll have negative 2k equals negative 8. So when we divide, we find that k is 4. So again, they're telling you what your remainder should be of 28 when you substitute in negative 2. So that's how I knew what to set this equal to. So basically you're just substituting in, solving an equation for k. Hope this was helpful.